How to classify this different phototransducer based on their sensitivity, their response characteristics, that is the spectral characteristics, then based on the circuits, and finally the application in visual photometry. Okay, so as we saw in previous videos, there are three different types of phototransducers. One is emissive type, conductive cells, and voltaic cells. Okay, so emissive photocells are some things that have physical structure like this, which has a photocathode and anode inside a vacuum tube. So when the radiation strikes on the cathode, it emits electrons, and these electrons, kinetic energy of the electrons will directly have an effect on the electricity as the flow of electrons of the current, and this current can be measured in the output. Okay, so their circuit is something like this, which has a microammeter, because the output is in terms of the microammeter, and they can be they and ammeter and resistor. Output voltage can be measured across them. Okay, so this is one such kind of an transducer, and the measurement of luminous flux and luminous intensity using the phototube. So okay, so what is this luminous flux? So the luminous flux can be given by the following derivations. So photoelectric sensitivity is defined as the IB, the current output, equal to S into F, where S is the sensitivity, F is the light flux, the incident light, and photoelectric current. So the output current to the input light flux is sensitivity in these terms, and it is measured in terms of watt or in terms of lumen. Okay, so how do you basically write the photo sensitivity? That is, you draw the, in the characteristics, you draw the, in the increasing part, you draw the slope. The slope here is the dy by dx, that is the output current, the anode current by the anode voltage. Okay, so here also the slope is output current by output voltage. So since the output current, so the output current by the input anode voltage will tell you about the anode gas filled characteristics. Okay, so then comes the photo multiplier tube. So we have seen this photo multiplier tube. A light falls on the cathode, electron is produced. This electron is then jumps onto the diodes. This diodes will produce further electron. When this electron strikes a diode, and extra electron is produced, and these extra electrons are results in the avalanche effect and produces more electrons, and more electrons falls on the anode, results in the current. Okay, so how these characteristics are even meant, we will see here. And this is a conductive cell, so the resistance of this changes with the incident radiation, and there are different materials that can be used as photoconductor. The other and this is the spectral characteristic of photoconductive cell, and for different material there are different characteristics, and you draw the slope for this characteristics to get sensitivity. And what about the responsivity? So responsivity is basically the how your system responds to the incoming flux, light flux or luminous flux incident on the photomaterial, and what happens to the output current. Okay, so this is the anode characteristics of this thing, right? So here your response, so there is no delay in response. So when there is an incident flux, there is a change in the current, and there is a change in the voltage. There is a change in the anode current, and there is a drop in the voltage across the anode. There is voltage difference across the anode. And so these are the different spectral responses. And what do I mean by response lag is how much your system responds when there is an input. So for a specific input, how much time it takes to respond is the response lag. So those things you can see in characteristics of the specific instrument like photodiode. And here if you see the photo current, okay, that is the reverse bias current is directly proportional to the incident radiation. So incident radiation is given by the luminous flux is given 750 watt, or irradiance is given by watt per meter squared. So how much energy is influx per unit area gives your input flux. Okay, and different flux has different photocurrents during the reverse bias condition, and different photocurrent so that photocurrent is directly proportional to the incoming flux. So you should be very clear when you are writing, when you are drawing the sensitivity, because the sensitivity is basically the output to input. So what is output here? What is the input here? Flux. The sensitivity is the ratio of flux to the input, ratio of the output photocurrent to the input flux. Okay, you cannot take the slope of this curve because it is reverse bias. Similarly, you cannot take the anode characteristics, you cannot take the sensitivity. You can only take the sensitivity when the y-axis is the output and the x-axis is the input. Okay. Similarly, here also it is voltage and this is collector current. So during the reverse bias condition, the collector current is directly proportional to the input flux. Okay. And here if you see, there are the responsivity measures and detectivity measures that you can clearly understand with the formulations. These are not very much important to the content of the course. So what we will be seeing is what happens to photovoltaic cells. So these are another semiconducting devices. So at the interface there arises this electrons, and these electrons produces the current. Then they move to the respective electrodes, and their characteristics are given like this. So this is a spectral response characteristics, where the luminous flux, the input, increases the changes in the current. And if you draw a spectral sensitivity slope here, this is the sensitivity slope. So kindly remember, the sensitivity slope depends on your characteristics. So the input x-axis should be the flux, the output should be what? The output should be your the measured quantity. Okay. And the rate of responses of so this is the response lag. So time constants is the 20 microseconds, 2 milliseconds, or different response bands for different types of voltaic cells. Okay. And finally, here comes the photo cells and physical photometry, and this is one kind of an applications of photo cells. I leave it to you guys for the sake of discussion, since it's self-explanatory. You can read it and you can write what are the importance of using photo cells in physical photometry. Okay. And another important stuff that I wanted to teach you is the response lag. So response lag is defined as when there is an input, how much time it takes for the output to respond. Okay. And so that is somewhat defined by this time constants. Okay. Thank you guys.